x plus h plus 1 over 3x plus h minus 2. 3x, 3 times h is 3h minus 2, and that's f of x plus h. F of x plus h minus f of x over h is x plus h plus 1 over 3x plus 3h minus 2 minus f of x, so x plus 1 over 3x minus 2 divided by h. Again, we have a over b minus c over d, ad minus bc over bd, a over b minus c over d, so it's a times d minus b times c over b times d. F prime of x is x plus h plus 1 times 3x minus 2, x plus h plus 1 times 3x minus 2 minus x plus 1 times 3x plus 3h minus 2, x plus 1 times 3x plus 3h minus 2 over 3x plus 3h minus 2 times 3x minus 2, 3x plus 3h minus 2 times 3x minus 2. X times 3x is 3x squared, x times minus 2 is minus 2x, h times 3x is 3xh, h times minus 2 is minus 2h, 1 times 3x is 3x, 1 times minus 2 is minus 2. Now let's expand this. X times 3x is 3x squared, x times 3h is 3xh, x times minus 2 is minus 2x, 1 times 3x is 3x, 1 times 3h is 3h, and 1 times minus 2 is minus 2. And this is over 3x plus 3h minus 2 times 3x minus 2 over h. And let's see, 3x squared minus 3x squared is 0, so these two cancel. Minus 2x minus minus 2x, 0. 3xh minus 3xh, 3x minus 3x, and minus 2 minus 2, minus 2 minus minus 2 is minus 2 plus 2, that's 0. And we have minus 2h left on the left and 3h left on the right. Minus 2h minus 3h, that's minus 5h. We have minus 5h divided by 3x plus 3h minus 2 times 3x minus 2 divided by h. Again, this is like h over 1, and a over b over c over d is a times d over b times c. So minus 5h times 1 over this times h. So this times h. And we cancel out the h. So limit of minus 5 over 3x plus 3h minus 2 times 3x minus 5. We sub 0 for h. This is 3 times 0. It's 0, right? And so the derivative is minus 5 over 3x minus 2. This is not 5. This is 2, by the way. So 3x minus 2 times 3x minus 2. That's minus 5 over 3x minus 2 squared. 3x minus 2 times 3x minus 2 is 3x minus 2 squared. We found the derivative of x plus 1 over 3x minus 2. It's minus 5 over 3x minus 2. Okay, f of x plus h is root of 9 plus x plus h squared. A plus b squared is a squared plus 2ab plus b squared. f of x plus h is square root of 9 plus a squared, x squared, plus 2xh plus b squared, h squared. The derivative is the limit of f of x plus h, which is this, minus f of x over h. So 9 plus x squared plus 2xh plus h squared minus root of 9 plus x squared over h. We multiply top and bottom by the conjugate. Square root of 9 plus x squared plus 2xh plus h squared minus 9 plus x squared times root of 9 plus x squared plus 2xh plus h squared plus root of 9 plus x squared over 9 plus x squared plus 2xh plus h squared plus root of 9 plus x squared. A minus b times a plus b is a squared minus b squared. A minus b, we have a plus b, 9 plus x squared plus 2xh plus h squared squared minus root of 9 plus x squared squared over h, 9 plus x squared plus 2xh plus h squared plus root of 9 plus x squared. The square cancel the root. We have 9 minus 9, 0, x squared minus x squared, 0, 2xh plus h squared over h, root of 9 plus x squared plus 2xh plus h squared plus root of 9 minus x squared. We can factor this term by h, right? So if we pull h out, we have 2x plus h left, and then we cancel h and we plug in 0 for h. 2x plus 0 over root of 9 plus x squared plus 2x times 0 plus 0 squared plus root of 9 minus x squared. 2x plus 0 is 2x, so we have this, and 2x over 2 times, I'm sorry, this is plus, right? Okay, I have a plus here. I don't know why I wrote minus, sorry. 2 root of 9 plus x squared. Can I cancel the 2's? Of course. So the derivative is x over root of 9 plus x squared. This is the final answer. The derivative of root of 9 plus x squared is x over root of 9 plus x squared. F of x plus h is 2 over root of x plus h. So f of x plus h minus f of x over h is 2 over root of x plus h minus f of x, 2 over root of x over h. We have a over b minus c over d, and we know this is AD minus BC over BD. 2 times square root of x minus 2 times square root of x plus h over BD, square root of x plus h times square root of x so this whole thing over h. Now this is h over 1, a over b over c over d, AD over BC, limit when h approaches 0 of 2 root of x minus 2 root of x plus h times 1 over root of x plus h times root of x times h. Now we're going to multiply this fraction by the conjugate of 2 root of x minus 2 root of x plus h. 2 root of x plus 2 root of x plus h over root of x plus h times root of x times h times the conjugate 2 root of x plus 2 root of x plus h. And we have a minus b times a plus b. It's a squared minus b squared. So limit when h approaches 0, 2 root of x squared minus 2 root of x plus h squared over this. Now 2 root of x squared is 4x, right? 4x minus 2 root of x plus h squared is 4 bracket x plus h, because the square cancel the root, so we have 4 bracket x plus h. What if we expand this? We have 4x minus 4 times x is 4x plus 4 times h is 4h, and see 4x minus 4x is 0, the 4x cancel and it remains minus 4h, minus 4h, and we can cancel these h, and if we plug in 0 for h, this is 0 and this is 0. F prime of x is minus 4 over root of x times root of x. This is the multiplication, bracket 2 root of x plus 2 root of x. Root of x times root of x is x, and 2 root of x plus 2 root of x is 4 root of x. So this is x and this is 4 root of x. So f prime of x is minus 4 over x times 4 root of x times 4 root of x, and we cancel out the 4's, so the derivative is minus 1 over x root of x. The function 2 over root of x has the derivative minus 1 over x root of x, minus 1 over x root of x.